And welcome back. Thanks for joining in. So yeah, today I'm just going to be basically continuing on from last week, which was continuing on with from the week before, which is just rounding out the last number of features for this language. Right now we're stuck in the middle of object destructuring. Um, I've had a few ideas since last week as well regarding some of the thoughts that I had brought up then. But for the most part, yeah, just going to be getting stuck in. A good chunk of the destructuring was started last week, but even as the development was going on, it threw up a number of kind of extra bits and pieces to be taken care of. So yeah, I'm just going to be working on those today. Hopefully get all of the object destructuring sorted out. If that goes well, might even be able to get anonymous functions implemented today as well. We'll see. And again, we'll be working towards just getting the last number of features for this language implemented and rounded out. So, to get started, first of all, I want to start off with, just before I actually do get stuck in with the implementation, I'm going to discuss. So there was this self-bind shorthand, that's all right. One thing that I wanted to address was a consideration down here, allowing non-string shorthand for object literals. So allowing this kind of a syntax. So if you would have a field name mapping to its value, then if it's a simple string, then you can leave out the string delimiters. I'm actually going to decide not to do this. And the big reason for that is, and I'd actually thought of this before, and only just working on JavaScript during the week reminded me of one reason why we wouldn't want to do this is because in, say, the likes of JavaScript, we can do this kind of a syntax, but what it then prevents us from doing, and what I found counterintuitive for a long time, and it also requires extra workarounds, is the fact that in this kind of setup, you can no longer use variable names kind of quite naturally here. So normally, in this kind of syntax, if I wasn't used to JavaScript, I would say that this would be the value that A contains. So if A is actually, contains the value let's see, ABC, then this would actually assign 1 to ABC. And I feel that that's actually a more, for me, that's a bit of a more natural way of doing things. I think, well, maybe, again, just thinking about it a bit more now, maybe since this is the most common way that, like, we're probably going to use string literals more often than string variables, but that are then are computed values here. The other thing though is that if we say in the likes of JavaScript, there, it's recent to me, but a recent development is you can do this, but now you need an extra notation like this to actually say, okay, you actually compute the value in here instead of, if it happens to be a literal, it basically compute this instead of doing the normal processing. And I feel like it's a bit more natural to just say the default is that you process it like a normal key. But then if it's a string, then you can actually use it as is. So I think we'll do it like that. So I'm not going to allow, so string literals, or we're always going to expect a string here, and the default is going to be you'll just specify a string literal here. We're not going to have a shorthand syntax for those keys, because the other aspect, probably not again, not a big issue, but if you decided, again, say in the likes of JavaScript, where your keys are going to or your fields are going to use hyphens instead of underscores for whatever reason, and you had a field name like that, again in JavaScript you'd have to do something like this, whereas in this language this is actually going to be the shortened version that we're going to use normally. So yeah, so that was one development I thought of during the week that I just wanted to add to my little to-do list. So then, with that said, yeah, I'll just get stuck in and continue on with the next bit of evaluation, I believe it'll be. So self-bind shorthand. So now again, because we're not allowing this kind of object shorthand, this will be something like, so instead of that, we will allow this. We allow that. So it would be a b is equal to yeah, just considering whether that makes as much sense, or if it's even something that needs to be implemented right now. It's a nice to have, but I'm actually going to put it into the rest in with the rest of the to-dos, because it's not the most essential. It is nice to have. I use it quite a good chunk in JavaScript myself, but it's not essential, and I suppose I probably could think about it a bit more before jumping into it. So that's that. So I actually just, yeah, won't be implementing that. Allow renaming. I think with that makes more sense. So we'll we'll go ahead and implement that one. One thing that I want to confirm as well is if we are allowing evaluation there, evaluation of keys. So if a is equal to y, and we do an assignment like this, bit of a weird one, but it should give a result of y is 1. So with that, then Nice. Okay, so first of all, allow renaming. So okay, that's one thing, because last time we were saying that the new variable name is actually going to be on the right, isn't it? This that makes things a bit trickier, because it's, again, I keep confusing, say, destructuring with initializing object literals. And do I want to allow literals here, for example, for renaming? Let me take a look at what's currently implemented. So with destructuring, so with literal initialization, you have to have the strings, and I think that makes sense. With destructuring, you can't have the strings, and it's all referencing field names. And it's all the shorthand. Yeah, it's a tricky one. And the obvious solution is actually less obvious than I was thinking, so I'm not sure if I'll actually proceed with it how I had been thinking before. Because again, I would like some consistency with all this stuff. The thing that kind of threw me during the week was this idea in JavaScript that, okay, if you want to evaluate, a key, it has to have a special syntax. And I was like, of course, I could just continue on with this as well. And it has its own merits too. It means that, when you do have keys following this standard syntax, which is going to be most use cases of it, you do have a shorthand for it. But, adding a special notation for what is, could still be considered a common use case. Yeah, I'm not sure. But then even this use case, this would actually no, this wouldn't be again, I keep going back and forth. This wouldn't be as common a use case as I'm thinking about, actually, because this, I suppose, in this new language, and similar to JavaScript again, there are going to be two situations where you're using objects in general. You're using it as an actual, object type. It would be an equivalent to an object in Java without, any class behind it. But it's, a set of kind of static fields where the language itself knows what fields that are there, and it expects them in that place. And then the other use case is, you know, almost like a dynamic object, a map, where you don't know the keys ahead of time. They can be added or removed at any time. And so, this doesn't necessarily, like, the support of this is a bit of a kludge, so to speak. Like, like I said, I have used it a bit recently, but thinking about the use cases actually probably would have made more sense if I didn't. I probably just used it because it was there, but not for a good reason. So yeah, anyway, long story short, all of this stuff is probably needs a bit more planning, a bit more reasoning about it. So I'm actually going to there's the unspread and reassigning names. Yeah, I'm actually not going to work on these today, I don't think. Now that I think about it a bit more, I'm going to potentially plan it out a bit better and see if there's a more consistent approach that I can use. Having said that, so I need to work on something today, so I suppose I'll just jump on to these anonymous functions. So in that case, let's see what we have here. First we need a syntax for that. And yeah, I wonder what would be a good syntax for this. Let me see if I can pull up this example of higher order functions, and in this case, instead of half being defined like this, maybe I could just define it like that. Kind of JavaScript style. Again, some alternatives are, I don't think I'll allow, so an alternative is something like this, or we could replace that with that. I don't think I'll allow the parameters to be unparenthesized, again, just for consistency. And I won't have the this lightweight option that JavaScript gives, even though it's nice, but yeah, I won't be supporting that, at least for the moment anyway. I suppose the two options then are whether to have basically what syntactic approach I'll use. And like same number of characters, same number of characters. So realistically, it's kind of much of a muchness. I'm inclined to go with this version, again, just for consistency. I'll just check if it results in an issue in terms of kind of ambiguity and things like that. Like, but it probably shouldn't. The only thing is, there is something about this syntax that just, again, even though it's the same number of characters, it can feel a little like it somewhat feels a little more lightweight, even just because there aren't, letters involved. Let me just think. So if I had both of them, and if I was using the literal version, the literal form directly, let's see. Much of muchness, really. Yeah, as you'd expect. I actually, in this circumstance, I probably prefer this. Yeah, whether it says FN or whether I use an arrow symbol, isn't going to be the make or break for this. It's really going to be the other things involved, I think, such as whether there is this kind of a lighter weight notation. And can this allow for a lightweight notation? If this was going to be allowed in future, that would probably look better. But then how often do I personally even use stuff like that? And I don't even like the look of it when I do encounter it. Sometimes, yeah, personally, I find that of little enough value. So I'm going to, for now anyway, yeah, just say that that's going to be the function literal syntax for now. So this is then, so now we'll see if, if that's even possible. So it's going to be an expression, and let's see, I'll probably grab the same definition from up here, but just change it so that it doesn't have an identifier there. Has no name, so it's an expression, a function expression rather than a function statement. That's an interesting distinction. And let's see, I should know pretty quickly if, okay, it doesn't look like there's an ambiguity. No, that seems to be all right. Nice one. So the issue now is just that there's no support for that type of expression just yet, but that's easily solved in my opinion, I hope. So let's see, expression, that's an expression call, and we already have a definition of functions. So this is a, you know, for creating a new function and assigning it to a name. And now we're just gonna have the same thing, except the function value is just going to be returned as is. So yeah, take the function as is, and that is that's nearly all there is to it, actually, I think. 707, okay, expect an arc, so yes, we need to wrap it up in an arc mutex, so a new val ref. Okay, what's the issue here now? So this seems to be the last error that's left, just a non-exhaustive pattern, I think. For trying to bind, yeah, that makes sense. So func cannot bind to a function literal, and so now the issue is an unexpected token fn. Interesting there. because I need a, because this is now different. This is an actual function expression. It needs to be terminated with a semicolon, I'm guessing. And unrecognized EOF, again, I think that's an issue with the sample there, actually. That needs a semicolon at the end. And yeah, that's what we'd expect. And similarly, if I commented out that, I could do my function here and say n, return n divided by 2, and it should give the same result. Yeah, nice one. So that's function literals implemented. Let me see. Go down to the to-do list. So then I better add this new function handling. Nope, won't have that yet. AST and yeah, blah, blah, blah. And commit that and we'll verify. Add support for anonymous function literals. And nice. So then the next thing to be done is, I suppose, supporting the basic operations for the built-in objects. So we'll also have plus addition, division, multiplication, addition, subtraction, multiplication, division. What other operations are there? So we have bitwise operations. We have modulo. Yeah, I suppose modulo would be useful in there. We have equality. Anything else? So we need Boolean operators. We need not. Basically just looking at my keyboard now if there are any other things I'm forgetting. We have greater than, less than. Strings, we would want to be able to append them. There's also for, what am I calling them? Arrays. In fact, I think I have these written down somewhere. Let me just pull up some of my notes. So projects. Nope, I think that's probably about all I need. And, Yeah, and this is just a shorthand for appending arrays. Yeah, I'll need to support a number of array operations in future as well. But that won't be quite necessary for getting started with using this language for research purposes. In fact, how many of these are? Probably not a lot of them. Yeah, so I suppose I'll just start implementing some operators first, and there should hopefully be some time to take a look at the type built in, which should be very straightforward as well. Just returning a string depending on the type of the parameter. So let's see, AST. I'm going to LALRPOP. This should be relatively straightforward again because we're just using the built-in Rust implementations for a lot of these. Yeah, so this will be multiplication. What's the order? So it's a factor, and then it can be, that binds more highly than a term, I believe. And that can be a plus or a minus. And similarly, these all have compatriots up at this end. And more. And so then if I want to add support for those, so if it's an integer, yeah, and we want to allow so some subtraction, keep playing division first for some reason, and multiplication and division, subtract, let's do some tests for this. Print 4 plus 2, or maybe 5 plus 2, 5 minus 2, 5 multiplied by 2, 5 divided by 2. So we have 7, 3, 10, 2. That's what I would expect from those. And if I said multiply by 2, multiply by, let's see, 1 plus 2 multiplied by 3. So this should be 7, this should be 5. Oh, I probably skipped something in the parser recursion rules. Let's see. Yeah, that would have to be a term. So the recursion wasn't working correctly there. So that's not what I would expect. I would have expected, yeah, so this is actually binding it in the wrong direction. So I want it to bind the multiplication first. So like it should bind like this. It should give the same result whether the parentheses are there or not. And that's giving 7 now. So yeah, I need to sort that out. So factor should will need to come after term. Yeah, and that's working as expected now. So let me get rid of those two, and that also handles the assignment version as well. So that if I do x is equal to 5, x plus 1, x minus 2, so that's 6, 4, 12, and 3. So then the result should be 3. Oops, no. So 5 should be, that should be 6, and then 4. Ah, interesting. So what are the actual results we're getting? So I'll comment these out, put them down here for the moment. So I should get 5, 6, 5, 6, 4 for the first 3 anyway. Yeah, 5, 6, 4. And then multiplication gives me 1. And why is that? So multiplication seems to be correct there. So it could very well be in the parser I'm assigning the wrong yeah. Mul and div. So then the result at the end should be 3. Nice one. Okay, so that is the integer operators. Well, actually, I might as well just plow on and do all of them. And so then going to the parser, we won't be adding a shorthand for these, but we will be adding them down somewhere here. I'm not sure the binding for these actually. They would probably want to bind fairly loosely, which is why I think it's up here. So this is the loosest binding, and down here, including parentheses, is the tightest binding. So including literals. So in that case, we'll have greater than, we'll have equality, and we'll have non-equality. And I don't have any samples for that, so let's set some up. Shall comment them out again for the time being. Print 1 equals 2, 1 not equals 2, is greater than 2, and 1 is less than 2. So we should have false, true, false, true. Yep. So so with that in place, then I think I'll just add that as its own little atomic change. Add were there other integer operators? I think there might have been 2 others. Let's just double check. Modulo, yes. I'll stick it in here with the factors. AST, and then the evaluation. And just do a quick testy test. And 5 divided by 2, modulo 2 should give us 1. And 6 modulo 2 should give us 0. Yep. So I'll restart this. So that's those gone from the to-do list. So that was under basic, I think. Which came after assignment. So then the next one, I could just do, yeah, I suppose I'll do Booleans next. First off, I can, yeah, I suppose I'll add the remaining operators so that they're all there. And or not. I'll add parsing for them. So not should bind loosely. Usually these operators are on 2 items. So actually what I'll do for the moment is I'll remove support for not. And we'll say instead that we'll have, similarly to these, the Boolean operators will bind very loosely. Now this will mean that these will return an error because I'll just say unsupported. And later I will output the actual operation in the error message. Or maybe I'll just do that now. Can I do that? Can't be formatted with the default formatter. Maybe I'll just use the debug formatter for the moment. Yeah, that's all right. So then, just as a quick test, I'll do that, and it should say unsupported operation for integers. But then, if I do from false, and I say that that's a bool, what do I have as the field for bools? Just B. Oh, I haven't defined the literals, the Boolean literals. So quality will be the same in those cases. Won't support greater than or equal to, but will have and or. And then evaluation, no. Oops. Did I even? I don't think I even have those support for those in the AST just yet. Nope, I don't. So then I'll need to add support for those. So then line 762, expected Boolean but found a reference to one. And why isn't that an issue with the integers, I wonder? Dereference the borrow. And it's only with the, so it's with the or, and it's with the and. That's kind of interesting. So I get references to those. Oh. Cool. So that should give true. That should give false. So what do we have? False, true, false, true. So what was the first one? False as well. Nice one. And so in that case, yeah, I think that's enough to make a commit as well. Maybe I'll first add the support for the Boolean literals. and then the last one, and the last Boolean operator I need to sort out is not. And so that should be straightforward enough to implement in the AST in the parser, but it's the AST that I'm hoping to kind of simplify if I can, but I'll probably just have to add a new I suppose, yeah. Yeah, I think I know how I'll do it. So again, yeah, very loose binding. So so we'll have change all of these to be unary op. Whoops. Oh no, those are meant to be binary op. So unary op will be changed to binary op, and regular old op will be now unary op. So then so I'll add some boundary checks on this regex so that it doesn't so all the existing stuff referencing an op should be a binary op anyway. That's kind of neat that the op assign should always be a binary op. This will be not. And so, whoa, that's not good. So, ambiguous grammar, wasn't expecting that. So let's take a look. Oh yeah, no, that would. Although. Is it that this should be very tightly binding? Like as in down here? Woohoo! Maybe not. Well, first of all, it's not even illegal. So the issue being that if you had something like not this divided by this, then it could refer to not factor or the result of not factor divided by expression. So if you had not factor divided by expression, then it could be not factor and then followed by expression, or it could be factor divided by expression and then inverted. So and this isn't an issue with the likes of this, of the rest of these, because these have closing delimiters so that you know when the production ends. But this would, this doesn't. So what do I want my rule to be? I want it to be that in this scenario, do I want it? I think I want it to be tightly binding, so I would want it to be binding to factor. But how do I denote that? Could I just put it in with the more tightly binding stuff? We shall see. Okay, so that works. So what was so it was just because it was calling into expression. It was saying that could be any term and any factor. To be honest, don't 100% understand why that fix resolved it. But it should be all right. Anyway, onward and so on. So let's see. Non-exhaustive pattern 463. So I have coverage for binary operators, and I need to add support for unary expressions. So let v equal that. let result equal that. RHS. I should be able to just do it on V, I think. Whoops, what happened there? So what's it called? Binary operate on binary, binary operate, unary operate. What's it called when you have a certain number of parameters? Let's see. Dyadic. Monadic and dyadic, yeah, okay. Operate, monad, operate. No. Apply, yeah, unary operation. And then, so it was apply binary operation, and so next we need apply unary operation. Oops. And so this will be a bool b and then the only operation that is possible at the moment is a not. And that covers all of those operations. So now let's see what is what's left to do. So 642 results. It's still not covered by something. Line 240. Cool. So that gives us false and true. Nice one. So that is all the binary operators sorted then. And support for operator. All right, so that that takes care of another chunk of operations. So that's the Booleans done. And next we want operations on strings. So apply, was it binary operation? So now if we have two strings, this should be relatively straightforward. Although maybe not, because strings in Rust can be a little trickier, but we shall see. Wrist is getting a little sore. Can't be used to concatenate two of those kind of strings, so I need to do that apparently. And let's see, does that have the intended effect? So I'll just have to make sure that, like, I don't think it would mutate it in place, but I just have to double check. Interesting. What happened there? Why didn't Pat on oh wait, sorry. No, that's just me being silly. Whoops. Invalid token. Oh yeah. I'm not even using the right syntax for my own language. So we have hello and hello world. Yes, so the original didn't get mutated, and let's just, for funsies, let's say S2. We add a little bit at the end too. S3, yes, isn't defined. So we'll add that. Catenation or concatenation? Both are correct, are they? Maybe not. maybe concatenation is probably more appropriate in this context. So that's strings done. Oh no, sorry, I need to also perform an equality check. EQ would probably be nicer, more consistent. I might change that in time. But anyway, for the moment, that's all good. Boolean LHS is equal to RHS. And yeah, that's true. And that should be false. So true and false, yeah, add support for string operators. So that's that done. And then array operations. This will be slightly trickier, but still shouldn't be a massive issue. I think they're called lists in this at the moment. And it'll be also sum. So let's just try that first. So that's x's, and yeah, so this will be slightly trickier because they don't automatically copy. Oops, where have we gone in my file? So I need to actually get them into mutex guard. So I need to unlock the mutexes and although do I have to? They should probably be already out. They should already be unlocked by that. So I should hopefully be able to, if Rust allows for just kind of again a concatenation Rust vec. So a one where it's not a mutation one. So that's concat. That should work for my needs, I think. I'm missing something here. Oh, I just need to remove that, don't I? And I need to put it there instead, actually. Method can't be called on that. Yeah, I have no idea what that means. Following trait bounds are not satisfied. So I'm guessing that just means the elements within the array are individually not concatenable. Because these guys in here, as distinct from these where all the values are, directly there, the values in these lists are valrefs. So I will need to unlock, unlock those actually. So let me see. Let vals equals that for v in those vals push. I'll need to unlock them as we do in another section. So I need to could I just do this, perhaps let x's equals, and I'll just unlock them inline like that. Not found on a vector. Oh, because I have to unlock each of them individually. So maybe what I could do is let x's equals that, and I do for v in LHS, because I don't need to unlock the vector itself, and I don't actually need to unlock the values in it. I can just push a clone of the value and do this. Is it append maybe? No. Vec maybe. Expected a maybe now I can do push. Cannot borrow as mutable. Right. Expected. Do I have to know? Oh, very silly today. Okay. And we have liftoff, so then we're going to our test. And again, hello world. Oh wait, no, what am I doing? This is meant for arrays. And yeah, the result is then a single array with all those elements. Nice one. And I might actually do it the same way as before so that we verify that the originals are left unharmed. In fact, I should have done it in 3 variables last time as well, but I won't be going back. Print x's, print y's, and print z's. So yeah, the result has all those. Y's has 3 elements and x's has 3 elements, so the originals are unharmed. So that is array operations done. Add support for list concatenation. And so then that brings us up to 30 minutes to the hour. So then, or just about. So that's that section completely done. Nice one. That's a good chunk to get out of the way. So that brings us up to built-ins. So this will be very useful for things like reflection. So if we want, if I wanted to implement, for example, and that could be a niche project, even though the error handling thus far could pose a problem for actual debugging. This could be this will be useful for reflection. So built-in types. I'll call it type, and it'll be stuck in there in the global frame. Let's see, so we have the values coming there. It should just be one value. I should return an error if it's not. Handle out of bounds access, yep. Investigate casting usize to an integer, so the first value here needs to be a list. But in this case, for this function, it's going to be specifically for, in fact, this is an interesting kind of thought that, you know, in the implementation language, we have access to this information, like we have access to the different types. So far, there's no access to those types in the target language. So, you know, in the target language, we can't do this kind of logic where we check what is the type of the value and perform logic based on that. And that's what I'm going to bestow upon the language now is the ability to actually see what is the type of a given value. So this is probably going to be relatively straightforward, I would say. So this would be a value, and it'll be a string, and it'll be t. So in the case of null, it'll just be null, and so on and so forth. This kind of goes against my coding convention here, actually, but although no, there shouldn't be any unmatched case. So well, I hope there won't be, but we shall see. So there's bool, there's int, there's string, there's list, there's object, and that's going to be distinct from list and string. Here's an interesting one. We'll be using built-in func, or func for both built-in function and non-built-in functions. Interesting. That shouldn't have any real-world consequences. And furthermore, I am hoping to consolidate both of these concepts in time, but this should suffice for the moment. So that should be more or less it, actually. Let's see if there are any issues. Yeah. So line 97. Expected a string, found that. Oh no. Okay, so there's no issues with that as such, so I'm going to throw that down with the other built-ins for the moment, because technically it's implemented. I'm not sure that it's actually working yet, but I shall hope. And so just a demonstration of the type of functionality that this will be used to enable. So we'll have, what will this be called? JSON stringify, yes. And we'll just have a v here. And the t will then be the type of v, and we will match based on that. So if t is equal to null, then return null. And I forgot the string format in my language again. So else if t is equal to an int, well, we can't actually. Yeah, at the moment there's no integer rendering function just yet. One could be implemented now using the integer operations that were developed earlier today, but I'll just say 6 for the moment. it'll always be, if we're stringifying a JSON integer, then it'll always be 6. What are the other types that I put in here? So there could be a bool, and then so if v, so we know that v is a Boolean, so in that case, if that's that, then we return true, otherwise we return false. Yeah, we have the t integer, we'll have, it could be a string, and that will be just rendering the string with quotation marks around it. Now, it doesn't escape the content of v, so this could be illegal and produce invalid JSON, but this is more proof of concept and kind of just more for illustrative purposes. So if t is a list, then the output string, we're going to build it up one by one. So we're going to say for v in for item in v, I'm going to say s is, or wait, we'll start with that. And I is equal to 0. If I is equal to, if I is not, so where do we put the comma? We'll, if it's at the start, so if it's not equal to 0, then we'll put a comma in. If and then we do a JSON stringify of the item, and we'll append that to s, and we'll say I is plus equals 1, and then s plus equals the terminating bracket, and we'll return s. I hope I'm not missing the semicolons here, because it'll be a pain to debug that because of the error handling in this language thus far. If it's a, let's see, if t is an object, then, oh, we haven't a for loop implemented for iterating over object items yet, actually. So that's one thing, we can't enumerate we can't enumerate objects, I don't think. I don't think so anyway. Yeah, we have only implemented for loop iteration on lists, so I'll have to add that to the to-do list actually, and that will be need to be implemented for objects. Though again, this language isn't necessarily meant to be full featured. It's probably implemented enough such that I can use it for the research purposes that it was originally intended for. So, but I suppose I'll still keep fleshing this out with features until it's, moderately it has the minimum feature set that I was intending to give it. But yeah, at the moment we'll just say, and again, this error itself isn't going to be handled properly. Well, yeah, the error itself. I don't have, is it called the semaphore problem? No, I don't think it's that. I think, is it semaphore? Basically, the fact that I can't distinguish errors from values at the moment in this language. I can potentially distinguish errors from values using kind of type switching and value overloading, but that'll be something that I'll be adding either to this language or the next one. Is proper, not proper full-featured error handling like exceptions and things, but enough error handling to make the errors distinguishable from regular values. So with that done, so I don't have support for objects, but at least this should be enough to demonstrate the concept of type. So unrecognized token if. I do have support for if statements, don't I? Unless I'm missing a semicolon somewhere. Maybe what I'll do is I'll comment this out and then put it all on one line, just to eliminate any errors. See where the errors are cropping up. So that's 76. I don't have support. I have support for ifs and elses, but not else ifs. My mistake. Let's see. I do think I want support for else ifs, at least for, if I'm not going to have a switch statement. I probably want to allow an else if statement. So, so what would this look like? So I can have an if, and then a block, an if, or an else, and else block. Can I put this can't remember how I do in fact, am I doing it anywhere here where I'm doing a star number of items? Doesn't look like it. I do think I am. Oh yes, I'm using star number of statements there, but am I doing it with a with parentheses anywhere? I wonder. Not that I can see. That could be a good indication that this is something to put in to potentially put in a new production. but I'm fairly, yeah, will I do that though? Probably not. So first of all, I'll try this. So basically just abstracting what I have so far. So we'll have an if cond, if statements, else statements. Does that compile? Named symbols like that are only allowed at the top level of a non-terminal. So I would have to do something like, maybe I can just split that into its own section. Going down a bit of a rabbit hole with this actually, and it's not, even though it's it'd be nice to have right now, it's not actually necessary. I can rewrite the code slightly because I'm returning in every branch. That means I don't actually need the else statements or the else if statements. So I can refactor it like this, and compile it like that. I do need to add that to the to-do list though, I think, is so there's object enumeration, there is list enumeration. So I think I have iteration over list values, but I don't think I have enumeration of lists just yet. So getting the indices and the values, and I also potentially want a string enumeration, but that's a bit of a can of worms, so I'm not sure will it be something that I do, but I'll add it to the to-do list regardless. Those are kind of turning into stretch goals at this point. So so I'll do an example, get JSON stringify, and I'll do a list because it's probably the most kind of yeah, it's the only compound type that I support at the moment. Jane Doe 6, just as a random. Oh, and those strings will have to be like that, and any other values true and no. So let's see what will come out the other side here. Null isn't oh, I have support for null values in the system, but not null literals. So yeah, let's go ahead and probably isn't even supported in the AST either, I would wager. So let's see. val, and there's no support for null values just yet. Oh, where is that? 240 again. No output, or is it just exceptionally slow? Probably in danger of crashing the computer. So what's going on here? Let's print some debug statements. So I'll print 1 as soon as it gets in there, and then 2 once it makes it past the type function. Okay, so I printed both of those. And maybe I'll do this on a separate line. And let's see, JSON, print the JSON. And print result here. This is probably the most sophisticated program that I've developed in this language thus far. So yeah, issues with it probably wouldn't be very surprising. Okay, so I'm guessing the issue lies somewhere in the recursion. We shall see. I'm probably going to get a lot of print statements here, one after the other. No, it's not just yet anyway. So it's not actually recursing. Curiouser and curiouser. Oh dear. Okay. Yes. Yes, this this could be a problem. So yes, so it's attempting to recurse on the value or to recurse on the function, but there's a mutex on the function. So it just can't. The mutex on the function definition or the function value is unlocked for one iteration of this call, but so it can't be unlocked to perform another iteration. That's so as it stands, this language cannot support recursion. Interesting. hadn't dawned on me. Probably should have, but okay, interesting. That will be a challenge to figure out, I think. And even if a shortcut could be taken to allow self-referential recursion or self-recursion, then it would still be a challenge to define mutual recursion between two other functions that are calling each other. Very interesting. Yeah, that makes sense. I wonder if that is such a problem. It might not be. So one reason for this, and I'll just stop this thing for the moment, but one reason for it is that when we call a function, we lock the whole function for the duration of the call. However, and that's probably fine for the built-in functions, actually. It might not be necessary to change that. But so we've got statements. Oh, and we've got the closure there as well. Like that's tricky. And we have the arg names. Because if we could get those out of that lock, then we could just continue on our merry way. Actually, that could be all right, because these are all val refs. So once those are collected, once the arg names have been used to create this inner scope, it should be possible to extract the inner scope from this guard. The statements, we'll check the definition of the function value. Statement is a vector of statements, and that's AST statements, I'm guessing. Yeah. Those could be cloned. The scope stack is also a reference, so that could be cloned. So actually, we should be able to extract out of this guard all the bits that we need. So oh, there's this trickiness with this part then, though, that makes things a bit of a pain. All right, but what I can do is I'll just create a temporary either type, and I'm not even going to I'm not too familiar with generics in Rust, actually, though. That's the only thing. So left. So does that compile? Okay, so that's compiling. It's not being used, but it compiles. So then I can put left in here, and then here what I'll do is right. I'll just put a tuple in here. I'll get the inner scope. Again, clone the closure, same as we would do there. Probably clone the inner scope. I can probably remove some of these clones in a second, but I'm just going to do what I can to get this working first. And then V is going to be matched again, match V. And if it's left T, then just give back the T. But if it's a right, now that we're outside the now that we're outside the guard, things should be able to progress on as normal. So I'll copy this stuff. And let's see if this comes even close to working. So right, so that's, those are ethers. Used in a pattern. Yep, that is correct. So that oh. Okay, that seemed to work. Like I probably shouldn't act. I shouldn't act so surprised, and should act a lot more confident. But I did think it would work in theory. I assumed I'd be getting a bit more resistance than I got. But I'm very happy with that. I thought that would be a lot more of a mess than it seemed to turn out to be in the end. I'll still have to fix up a big load of code, but that's a very cool proof of concept, at least, and I was able to resolve that that issue fairly quickly. That's really nice. I'm happy with that. So the stringified JSON then is it's, yeah, the rendering is kind of all over the place because Rust is also applying its own escaping to the double quotes in this string as well. But basically we have this array, stringified array, and we can see as well that even though we use our single quotes for strings in this language, they've been converted properly into the double quotes for JSON. We have the first string ABC, and we have the proper commas between everything. We have the nested array with Jane Doe. We have 6. Though if we change that to 7, of course, because we're not actually rendering the integer, we're just we just know that it's an integer, so we're putting 6 in there. But then we have true, and we also have null. So that's pretty cool. Will I fix up the code now or later? I suppose I will. Well, I'll commit some of the code that's actually working at the moment. So so first of all, there was the support for null got added. I won't add the definition of type just yet. So will I clean this up just now, just to make things nice? I think I will. Probably. Could I create a closure here, I wonder, to just simplify things? Even though closures have simplified nothing for me in Rust in the recent past. So yeah, maybe I won't clean it up at the moment, actually. There's probably a little bit of work to do in it to do it correctly. So yeah, I might just leave it for now. But that is, yeah, I think that could be considered to be the type function implemented anyway, at least. And yeah, maybe I won't commit the test code, but I think I can commit the actual definition for type. Oops. All right, so 9 commits today. That's not bad. So yeah, that's another bit of work done anyway, and things are getting very close to what will probably be not the final commit of this project, because I've been actually working, like, this has been the dev branch or the work in progress branch. So even though most of the commits are still fairly self-sufficient and self-standing, there are no tests, no proper tests. There's no not great documentation. The variables and things are leave something to be desired. So what I will be doing a separate on the kind of mainline branch. I will be doing cleaned up commits, but In terms of, say, feature development and adding new features and things, yeah, we're kind of quite rapidly approaching the end. These shouldn't take too long, really. One caveat about the list and object enumeration, though, is whether to have a special handling for for example, for indexes. It's typical in languages that you can, do for v in list or for vi in list, to be like, for each value in the list or each value and index in the list. But whether I want to support that or just, have it always like, for example, iv in values, and then if you don't want one of these, you can just, use an underscore for it. I'll probably just do that, actually, to make things simple. In fact, I'll just double check. I think at the moment, the implementation is it just goes through the values. It doesn't handle indexes. Yeah. Yeah, I don't think it's yeah, I think it's just going through the values, not the values paired with the indexes. Also want to update the for loop to allow object enumeration, like I was mentioning there, and also do string enumeration. Now that'll be tricky because, I want, the decision will need to be made on whether to allow if it'll be, say, Golang style, where you're going through it one UTF-8 rune at a time, or whether you're going through it one byte at a time, which would be more typical. I'd be, slightly more in favor of just kind of keeping it simple, but that'll need to be decided to weigh the advantages and disadvantages and see, like, I suppose the main thing to consider is, if you don't allow one thing, can you still do the other thing? Like, is there anything you're disallowing by taking one approach? So that'll be my main concern there. And I'll also probably want to do a chunk of these at some point as well, but I just want to have a bit more of a think about syntaxes and things like that, because yeah, it's a bit of a tricky area, but yeah, for the most part, that's today's stream done anyway. Thanks for checking it out, and yeah, I'll see everyone next week. Take care.